Swinburne University of Technology.
Routing protocols on new operating systems, and for teaching, which is probably applicable here, despite you guys have got a pretty massive lab, and then conducting research as well, and just wanting to test things out, run experiments again and again. And then on the industry side of things, we've got things like training new staff, just giving them something they can play around with in a sandbox kind of idea, or testing software-defined networking controllers or some of the emerging network programmability. So yeah, it's hard to get that sort of gear. So one solution is to take the router operating systems, and this is similar to what I talked about last time I gave a talk here, but that was looking at Quagga. But here we're looking at running Cisco router operating systems inside virtual machines. And then connecting these virtual machines together, and then from that we can build networks. So there's quite a few, well, Cisco, we've got like CSR 1000V, and other vendors are producing virtual machine versions of their either their routers or their firewall appliances or other network devices. And once you've got them virtualized, connecting them together, you can build reasonably large-scale networks, basically limited just by CPU and RAM. So it becomes a lot cheaper to run it on something like x86 than it would be to purchase that physical gear and just to wire it all up and get the space in the lab. There's quite a few benefits there. So what we have with VIRL is an extensible network simulation platform. So we're running the same router operating systems that would go out to production routers in a virtualized environment. So that can be used to many of those problems that we discussed just before. So modeling existing networks or planning new networks, and all the other different cases like teaching and research. You can scale from tens to thousands of virtual devices, depending on what kind of package you have of the platform. But you've made really limited technically. It's just by the CPU and RAM, rather than it needing to be by the amount of gear you can purchase. So that offers many benefits. The teaching platform for networking concepts, or teaching networking principles, and hands-on lab, and these kind of benefits that I sort of covered before. Automation tools, programmability, some of the emerging stuff around DevOps as well, trying to integrate Puppet and Chef and some of those other tools with network management. And some of the other advantages is integrating virtual and physical networks. So sometimes you need the full data plane realism of real gear, but trying to purchase a lab with 50 real items, real hardware devices, is prohibitive. So you can get sort of a best of both worlds, or a good trade-off between purchasing some real gear and then having virtual routers and connecting them together. And so that allows things like rapid iteration with what-if analysis and scenarios, especially in a teaching or a learning kind of scenario where you're just testing multiple things. It's quite easily to spin them up, take them down, and test new things. So in terms of the overall layout of what we've got, we have a front end where you can draw the network up, annotate that, and then send that off to, and that's where the work that I did presented last time, so my PhD work was taking a network description and then trying to build those bootstrap configurations from there. And one of the outputs of there is just a topology view showing what the different layers that we're building there, so something like whether you're looking at routing protocol for the IGP, for OSPF, or BGP, and showing visually what that looks like. I'll get to that in a couple of slides. Once the basic configs are generated, that's sent back to the user interface, so then you can edit that, whether you want to add in custom routing policy or whatever the situation is. So the idea is that you can easily draw your network, get some basic configuration for the routing protocols and the IP addresses, then add in the bits that you do care about. So rather than starting from scratch every time, you've got like a basic template that you can then add in and do whatever the bit you're wanting to study or learn about or experiment with. And then we have the simulation engine, which is built on OpenStack. So that's been quite interesting using that project there as it's evolved. So the topology is sent across from the user interface to the simulation engine, and then that will spin up the virtual machine. So traditionally OpenStack would spin up something like Ubuntu Linux. Here we're spinning up the Cisco iOS images and then connecting them together, and then that's forming the virtual network. And then you can connect into those virtual routers and do standard things, whether it's Telnet or SNMP or some of the emerging protocols like NetConf or 1PK. Anything that would run on a real router you could access on a virtual router. So that can be useful for the teaching or the scripting kind of scenarios. So in terms of the user interface, it's sort of the drag and drop the devices together, wire them together, and a bit blurry, and then get the the topology from there. So drag and drop network design is probably not that groundbreaking, but the convenience of having that, taking the high-level diagram and doing all the steps of creating the virtual machines and connecting them together can save quite a bit of time. And being able to add in separate virtual machines, so it's a little bit blurry there, but it's quite easy to add in routers or different, servers or different types of the router images, or add in other operating systems if you wish to, and packages on them, and then setting the basic configuration parameters. And then you can also, once you've simulated the network, access through this interface or through other pieces to log into those devices from there. So in terms of the simulation engine, which is running underneath, we have all the network descriptions stored in just a plain XML file. So one of the things that we've been really keen on trying to do is make that accessible, so you could draw it in the interface and then modify it by hand, or then take a description from a different software tool or network topology off the internet, or generate it in some script based on traffic patterns or something like that, and then use that to send across. So that's like a REST API with a standard open file format there. So trying to make it extensible for people to start doing scripting or other scenarios with it. And that will take that topology, whether it's come from the user interface or come from a hand or a script created, create the virtual routers, create the networks and the links, and then sends that off to OpenStack, which will do the instantiation of that. So one of the advantages with OpenStack is it takes care of a lot of the underlying pieces, including clustering. So if you want to build larger networks, if you've got, rather than just one large x86 server, you could have a whole heap of them together, and that becomes quite easy to send a much larger topology, so doing larger scale testing. That's fairly simple to send across to it. So OpenStack sitting underneath is, everyone's sort of familiar with OpenStack, kind of. So it's doing a lot of things these days. The main thing it's trying to do, I'm not super familiar with it, but the main thing is to, similar to what Amazon AWS or something like that, kind of cloud services, and the API was very similar to it in terms of saying the machines must spin up. There's a really good Australian research, Nectar, run a research cloud, I think Uni Melbourne, the host here, I'm not sure. And that's got built on OpenStack for researchers to get access to cloud computing throughout Australia. And that's built on the platform here, so you could say you want this machine spun up, and then it will take care of finding a server to place it on, and then spinning up that virtual machine with something like Ubuntu or Scientific Linux or something like that. So there's a few components here. The main one is really Nova, which is taking care of finding a place and starting that virtual machine up. And then there's other bits sort of go around it. Neutron and Quantum in the software-defined networking space is getting a lot of interest because different vendors are offering their networking solutions that can plug into that in terms of data center, software-defined networking between virtual machines. And then other pieces, so being able to store data and retrieve it, identity services, and then so for authentication, and then being able to actually store those images, so what's available for people, and then the APIs to be able to access that there. So we're sort of built on top of OpenStack, so we can get the advantages of things like the being able to integrate new images and being able to do things like the clustering. So that's another sort of extensible piece there. In terms of the topology files that we have underneath, it's just in an XML file, and that makes it quite easy to be able to share between different people using something like this platform, and being able to store that if it's being used for an experiment or teaching, and be able to start it again later. And then that can go, because it's just XML, something like a Git or other version control repository. So the bit that I've mainly been working on is building the automated network configuration. So this is what I would have presented last time. So we're taking the network topology, which you draw up, whether it's 4 routers or something like that, and then taking some parameters that the user would set, whether they're saying the protocols they want to run or which autonomous system they belong to, and then generating the basic configurations from there. So for 4 routers, saves a little bit of time. 20 routers, it saves a lot of time. And depending on how big it is, 21 routers is as easy to do as 20. So rather than having to start again from scratch or have a big incremental cost of modifying what you're playing with. It's quite easy just to add or remove a couple of things, regenerate it in a few seconds, and then go from there. So that really encourages people to play around with it, rather than having what's quite common is if people doing this sort of thing, having their one standard gold topology that they spend a couple of days preparing and then using that for everything that they do from then on, whether they're doing client demos or doing experimentation. So being able to spin that up means that people can play around with different scenarios or test out V4, V6, or different routing protocols or different routing platforms with minimal cost. So it really encourages people to play around with it and do that sort of experimentation and learning. And then we get the configurations out from there, which a user can then modify, whether it's in the user interface or just directly in the XML file, and then experiment from there. So we've got like the package where you can draw it up, click the buttons, have the virtual machines running, but the aim has also been to make each piece API accessible so that people can extend it or integrate it with scripts and do automation as well. So the auto-generating the configuration can save minutes, hours, or even for larger topologies, days, when you're looking at lots of different protocols and lots of different subtleties between them. And yeah, viewing the different configurations in there. The grey bar. And then one of the things we found that was getting lots of configurations between 10, 20, 30 routers. It's almost impossible to be able to tell whether that's exactly as you intended, whether the links, if we're doing just the bootstrap configuration, is created, or whether you missed a link or missed a setting. So we built in the ability to view what the different protocols look like. So if we take the network diagram that we drew up, then we could do something like here's just showing the physical layer view, so it's basically just identical to what we had there. But then based on the different parameters and the connectivity that's set on that on the original diagram, then we can start constructing the other different routing protocols. So for something like OSPF, it might only be links that belong to the same autonomous system. Or for something like BGP here, that's obviously a massive hairball, so it's just a full mesh. And that sort of indicates that route reflectors would be useful to use there. So you can start to see that looks pretty crazy, because that would reflect the amount of peering of order n squared between all the devices. So you can get a sort of a graphical view into what the bootstrap configuration engine is doing. I can show you some examples of that in the demonstration. So that's the quick overview of sort of what the core of the product is and what the platform. So in terms of the use cases, especially for clients or for customers, one of the big things is just being able to mock up a network and test that out, and that's much better than breaking production. It's very easy to break a simulation and just take it down, start it up again, or give it to someone, encourage them to play around with it and get familiar with the network. That for a network sort of this size or larger for customers, being able to replicate that in a test lab might only be feasible to have that just for the production engineers to use before they deploy it. Whereas being able to run it in a virtual environment means you can give that to a new hire and get them to play around with it. There's very little cost in giving it to someone. You can easily replicate it rather than having just one test bed that's restricted to a certain engineering team. And what happened with that slide there? And just using it for demonstrations for customers. You probably want to do that better if it's a demonstration for a customer, but being able to show a new technology or proof of concept can be quite powerful. And then in training and education, so for teaching and training, giving students hands-on access to labs, especially if you don't have a large lab. I guess it's a slightly different use case. At Swinburne, we have quite a bit of gear to play with, but being able to give students access to some of the gear. I was speaking with one of the other universities, and to do like BGP teaching, the most that they could scale during a semester is about 3 routers per student, and you can't really give them an idea of the nuances of a large internet simulation when you're only talking a handful of routers, but that's the physical constraint. So being able to give a larger test network or being able to integrate that with some real gear and get that combination can make for a much more realistic teaching case. And also for research, just being able to conduct a research on a realistic environment. So last time I talked about some of the work we're doing with one of the open source routing protocols, which was Quagga, which is useful, but a lot of people, it doesn't quite don't know how to phrase it, quite have that realism or, as regarded as being able to conduct something on a more, industry routing platform. So whether it's something on like Junisphere from Juniper or VIRL from Cisco, being able to test out and demonstrate whatever a research paper is trying to show, being able to show that those experimental results come from something that's been tested on production routing software can make it more compelling than on something like Quagga, which is good to iterate on, but sometimes having it demonstrated on the real routing protocols, especially if you're showing some BGP anomalies or something like that, that can carry some more weight, which can be good. And then that's legitimately available as part of this platform. And being able to test out new features and new capabilities. So some of the new routing protocols, we've been using this to demonstrate to customers or even internally, just to sort of give people an easy way to play around. Because even within Cisco, there's only so much hardware to go around for different teams or different developers wanting to play around with new technologies. So that's becoming quite big internally. And then different test beds to test out software-defined networking controllers or being able to play around with that. Somewhat like the iPhone simulator that might come with Xcode that you can test out, a new software application, and especially in software development where you might not have access to a test lab if you're developing some software controller. And as part of that, making it open and accessible with the XML file, being able to import topologies. So one of the things we had was Cariden MATE, which is a enterprise tool for network modeling and traffic analysis or traffic behavior testing and traffic engineering. And then other platforms as well can be integrated in, whether it's a GraphML topology format or you can probably do rocket fuel and things like that. So trying to make it easy to pull in topologies from different research topology data sets and being able to integrate that, which is quite useful for some of the universities that have been on the early stages trial at the moment, being able to take in those topologies and test how routing protocols would behave in a somewhat realistic topology. And then, so taking that in, that's sort of automatically imported in. And once you get to networks of this size or larger, being able to take that in automatically becomes a lot easier than drawing it up manually each time. And then from there, it can flow through the rest of the workflow. So we can pull in that existing physical network, get it into the editor, and then use that to build some bootstrap configurations. And when you're talking of a network of this size, manually creating all just the point-to-point IP addressing and the routing protocols can become very, very time-consuming and tedious and error-prone as well. So being able to have that base automatically imported, and then you could turn on V4 or V6 or change your routing protocol or add routing policy and see how it goes from there, can really encourage that kind of what-if studying. And one of the other really compelling things is because we're just running standard packets between them, because OpenStack's just forwarding standard packets, that can be hooked into external devices. So the virtual routers are just seeing IP packets and then doing routing stuff with it and then sending it out again. So that can be hooked into, like I mentioned earlier, external tools and hardware, or even if you're running something like a Ubuntu server in there, that could be connecting in and doing cacti monitoring, or just capturing Wireshark. So I think this is on one of the topologies I had earlier, but I just hooked Wireshark in directly. You can start to see all the different routing protocols that come up there, so that can be useful in, again, like a teaching example or just studying how a network protocol behaves, because this is standard Wireshark running just on my laptop connected to a server sitting over in the US. That was running the simulation, so it doesn't have to be all in one place. And that was just coming up in real time as the packets came across. So then I could log into the routers and change things or play around with it and see that data coming up straight away and tap into various points in the network. And one other thing that one of the other universities was really interested in was not so much the routers in there, but being able to put a couple of things at the edges of the network. So you might put a HTTP server at one end and then have some wget or something at the other end and see how that behavior works across a larger sort of network rather than just testing it on a local machine. So more studying, teaching at the application layer, but being able to have a somewhat realistic lower internet layers carrying that traffic. Or one other demonstration we did a few years ago on a different platform was looking at a scaled down version of CDN traffic selection and looking at links And you could do something like this here. So there's some different scenarios, not just about studying routers, but maybe having those routers as a base and then putting some other application layer pieces at the edges, because if it's a virtual machine that can run in OpenStack, in KVM inside OpenStack, then it can be run here. So that makes quite a few options. We have lots of people who would bridge, drop in a Ubuntu server and then bridge that out to the real world and then add in various packages, anything from apt-get that you can get, and then using that to hook in whatever they would be testing out before they put into the production environment. So yeah, that was with Wireshark. So this one's probably less useful here. We have the underlying platform in terms of its real diversity, and it's basically just simulating networks. Anything that you could do in a testbed network, for the most part, you could simulate. So it comes out in a number of different platforms. And there's a research program as well, which I think you guys are on now. I'll come back to the demonstration. We'll run through some more of the slides. I'm shaking. So we've had a few customers using this in a real-world environment. This was a few months back. So we had one of a UK ISP, and they were wanting to test out some MPLS traffic engineering with some fast reroute. And they're really wanting to understand what they'd need to do to change it, so doing some pre-deployment testing and setting up a few things. And the main thing was that they were they didn't really have enough lab equipment to duplicate their network. So they were one of the early people that tried out whether this platform would work from them. So they were having a reasonable degree of routers there. Not gigantic in terms of a simulation, but if you're trying to replicate that in hardware, what's that, like 27 routers and then connecting in from external traffic sources, that would be reasonably hard to duplicate in the lab, or get that gear on loan or something like that would be fairly prohibitive. So in terms of drawing up the topology, it's reasonable sized, but yeah, they're able to draw that up with the various, it's not very clearly shown, but there's different types of routers, a couple of different platforms, different icons out here, but they're able to test out how it behaves with different configurations of different router operating systems. And what they're able to do there was, test it out and give the key thing was giving their operations team some time to familiarise themselves with the new platform or the new configurations before they had it in production. So being able to get familiar with that was really important. And testing out their code changes before they put them out. It's basically all the benefits that software engineering would have in testing things beforehand. Doing this kind of simulation in broader sense for networking is bringing some of those software engineering principles into networking. And then another case study was where another ISP were wanting to re-architect their network, so adding some new peering and transit nodes on the edge of their network. And what they were wanting to do here was to work out the changes that they need to do to migrate their configuration across. And once again, it was limited lab equipment. So quite similar in terms of the scale of what they needed. But what they were able to do was because we're using the same router operating system, they were able to get production BGP feeds in. So they just hooked it into their standard BGP feed that they would be getting out from their production network straight in and feed that directly in. So obviously not sending traffic back out, but in terms of injecting the routes that they would see from the internet for their routes, so they could craft their policy across and see how that would behave there. So they're able to get real live traffic and inject it in, because once again it's fairly easy to integrate with existing networks. It's not just running as a standalone simulation. And then using their route policy language, so because we're running again the same system, they could just copy and paste that policy code across, test it out. So in terms of, that's what their network they were trying to do, add some more pieces down the bottom and have those BGP feeds connected in. So in terms of drawing that, is really just drawing it again in the simulation editor. And then they're able to get, in an hour or so to build that up, which would be significantly quicker than getting the gear and hooking it together manually. And then playing a traffic generator, getting that feed in, or you could just hook it directly into an external feed. And they were able to use that there. So in terms of seeing the routers running, you can see if you just do the standard diagnostic commands, you're able to get seeing all the routes appearing for their network, and then the large number of traffic paths that were coming in. So they're able to do realistic change validation. And then they're able to, take that one back out there. So it's a brief overview there. So we've got a little bit of time. I'll go through a demo. See if I can screen share. Cool. I don't know how to make it duplicate quickly, so. First of all, was there any questions? It's quite a broad covering. Yeah?
We want to take questions now.
What would work best?
I don't know. Let's take them at the end. That way
Okay.
we can demo record it
All right.
before the light goes off.
Where my screen? I don't have it mirrored, so in terms of drawing it up, we can see. So I don't have network on this one. So you can draw up the network. Drag and drop. Let's go back to design view. Probably slightly too big resolution. So we have access to the virtual machines here to drop in, and it's fairly easy if someone wants to bring in their own image or have your own image modified from one of these. You can add them in on the server side and then drop them in and then connect that in. The system will take care of creating those links with OpenStack. So for the standard routers, you can see like the links are created here. And then the different properties that we can set here in terms of the configuration. So let's make that one bigger. So we've got quite a bit of scope in terms of setting things like the ASN, choosing what routing protocol we want to run, setting routing for IBGP, and then setting up other things like MPLS or hooking into external tunnels, so external BGP, VPNs, etc. And then once the configuration engine is run, we would then get the configuration back. So a lot of it's repeated, but even though it's quite a lot of similarity in the configuration, generating that by hand just to get each of the interfaces correct or the BGP sessions can take quite a bit of time, even if it's just mainly copy and paste and just changing one or two IP addresses. So once you get into topology sort of this size, that becomes a lot quicker to set that up automatically. And then for different software images, so we've got, that was iOS, and then we've got the iOS XR and iOS XE. And I'm not actually on the network at the moment, but if it's run as a simulation, then you can load up the various routers and then telnet into them and then get the full prod. So you could draw a network, drag and drop in 10 routers, hit auto configure, get the IP addresses and the routing protocol set up, hit launch, come back in maybe 5 or 10 minutes and then log into a router and go show IP route and get the full routing table and being able to do ping and trace route. Basically like that, so you're talking like 5 minutes of setup time to have a working topology. And then from there you can do things like the, having a server and then SSH into that and being able to do various applications on there, or hooking out to some of the external connectivity, so bridging it out to physical equipment. One thing that I'm not sure if we have in this version that's certainly being worked on is having VLAN trunking, so you could just connect a few VLAN ports into various points in the network, have them broken out to a physical switch, and then port 1 of the physical switch connects into this route and port 2 connects into here, so you can get some quite powerful combinations of the hybrid network, very easy. So a lot of the pieces here can be done manually, but we're really trying to add a lot of layers on top of that to make it quick and easy to get up and running, or to pull data from different formats, or push it out to different things, whether it's a Wireshark packet capture, or doing some live topology visualizations. That's another piece we've been working on, is just getting the output of the different routing protocols and being able to show what's going on. Log into a router, turn a link on and off, and seeing the output there. So really trying to add a lot more layers of of trying to simplify the various tasks that people would do. So it's still reasonably early days of the project, especially in the kind of the research or teaching space, is something we're very interested in getting more feedback on there and sort of building up those programs there. There's a lot of potential. But in terms of the underlying platform, it is anything that you could do stuff with routers on, which is so broad, whether it is enterprise change validation or teaching or research or software development. So very kind of broad at this early stage. That wasn't much of a demo because I'm not on the network.
How lightweight are the OpenStack VMs, like you can in theory run
Yeah.
it from your laptop?
Yeah, so it's just a decent laptop. So like 16 gig of RAM can do it. Other people have had 32 gig of RAM laptops, certainly. So
Is it based on Zen underneath?
KVM, I think is what they're running. So it depends on the operating system image. I was spoiled in the early days because Quagga run in user mode Linux, so you're talking 32 megabytes of RAM per VM, which is really nice. iOS Classic for Cisco is about 384 meg of RAM, I think, and then that starts to go north really quick. So I think NXOS or one of the other ones is a couple of gigabytes of RAM. So they start to get big fairly quickly. That's still orders of magnitude less than what would be required otherwise. So they're not super efficient, but they're still much better ballpark, especially if you're just throwing more RAM at it. So on a laptop, you can do some, but for some of the bigger topologies, you'd certainly want physical servers, all the clustering and things like that. Yeah.
If I was doing that VLAN thing you were just speaking of,
Yep.
where I have some physical kit, can
Yep.
I push configs from here out to that physical kit?
Yeah, that's something that we're revisiting how we're doing the file format and how far into that we go. One of the big aims is trying to simplify a lot of the tasks, and that would be one of the big pieces, is that the other half of the network, those pieces that are sitting on the physical gear. So at least maybe giving the config snippet or something like that as well, or allowing that to be stored as well for people, is something I'm certainly interested in. Yeah.
And do you have any wireless Wi-Fi?
No, so OpenStack is just trying to get packets between devices. So one thing, I think they're running Linux Bridge underneath now. So one of the bits that can be done with there is like the Linux, I can't remember what the latest version is, but it was like the traffic control type of piece, which allows you to add delay and packet loss to a link. So we were thinking more along the lines of, we had that topology earlier from that we'd imported, it's disappeared, from Cariden, where you'd have, might have Sydney and Melbourne, and then you could infer from that, or if you're pulling it in from Rocket Fuel or one of the external data sets, you might know how far away the links are, so you could use that to do basic, packet loss or delay type of thing. So we don't have any of the actual images in there for that. So I guess the answer to that question would be, one side would be, do we have a virtual machine version of the wireless device? And then the other thing would be the radio propagation characteristics. And in terms of the packet loss and delay, that could be set through Linux Bridge or something like that. If you had, but you probably want some external system that could model what that packet loss or delay should look like based on radio propagation characteristics. So we don't have anything in there today.
And if a user wants to customize this router model, so how to do that?
In what sense?
Offline, there are similar kind of ideas like offline.
Yeah.
Online. So if we want to change some models like the routing model, we can go inside and drag and change some code in C or C++.
Yeah. No, we're not open sourcing our operating systems. So, no. I guess it depends what you're wanting to get with that. That if you want to test out some pieces, depends what the experiment was, but in terms of modifying the Cisco image, I guess that's the real company proprietary piece. But if you wanted to test a variation on a routing protocol or something like that, then that's where something like maybe Quagga or VIRL or one of the other routing daemons connected into something like this. So you could run, depends what it was, like that's a bit of a cop-out answer, but you could run Quagga on the server there and have that running a modified version of a routing protocol connected into some of the other devices, and then seeing how it interacts with the control plane code of a production router, like how it would work in production, modeling, you know, that kind of interaction. But if you're wanting to do it from scratch, then I guess that would be just running Quagga directly on it, and whether you'd need all the orchestration pieces. You could certainly just add Quagga into each of the virtual servers and run it that way. So it depends on the experiment, I guess. But generally the virtual machines would be kind of like a binary image that's just dropped in.
When you start stressing the networks out with lots of traffic,
Yeah.
the fact that it's a simulation,
Yeah, not good.
change the performance of
Yeah.
how things would behave. So
Yeah.
this is really
Control
checking
plane.
checking the control plane.
Yeah, control plane's very good at. Data plane, your CPU would just, you know, that's not great. And what we have here is really a virtualized version of the control plane, which is probably something I should have stressed earlier on. So we don't model all of the line cards and all those physical gears. There was another project which actually this user interface was used originally for, where they would model all the line cards as virtual machines, but one router then would become like 20 virtual machines. So if you only wanted to, if you wanted that high fidelity modeling, you could use that, but you'd be looking at like 50, 60 routers to model 50, 60 virtual machines just to model one router. So this is sort of a bit of that fidelity trade-off, but the control plane code is exactly the same. So it's really taking the control plane code and making it run on virtual Ethernet drivers. But you can do scaled down traffic, so that's what one of the things we've done a while back for testing, was just running 100K a second and then scaling back the policies based on that. But trying to do, you know, performance testing, not great. But once again, if you really need that kind of throughput, maybe 3 pieces of lab gear connected into a whole heap of this to generate somewhat realistic traffic connected to it, and having 3 real bits of gear that needs that high fidelity can work together. So some of those pieces, a combination, can work.
Questions?
Yeah.
Yeah.
Yes. I have started to use VIRL since Untitled.
Yeah.
So when you create your topology, you have to save all your configuration, because when you close it and you want to save it, to use it in the future,
Yeah.
you just use this configuration about the server actually and your data. If you have real data on server, because when you close the topology or the virtual, it's just cache or something like that.
Yeah.
Yes. What about server?
So extracting the configurations from the server,
Just
yeah.
configuration your data on server. For example, I want to use one of the servers, install Cariden, and
Yep.
then just dump all BGP routing on that server.
Mm.
There is a possibility to just execute this virtual machine just to form cache when you just
Yeah.
close your topology.
Yeah, so there's a couple of answers there. One was, if you remember way back on that OpenStack slide where there was a couple of the other pieces there, I think Cinder's the one, which you can save a whole image, so you can just basically take a snapshot of your server as just a massive, so it'd be like a few gig or whatever that Ubuntu image is, and then spin that up the next time. So if you're just running one machine yourself, that could work. If you're sending it to someone else, probably not as portable there. And that's something, depends on what it is. Basically, it's just running standard server, so any of the kind of DevOps tools, Ansible, Puppet, Chef, could be used to extract something from that and then save that. So where we log into a router today and just say, give me the running config, save that, then you've got it for next time. You could extend, or we could extend that to do some of the other things in the future. There's kind of a long tail there on people. There's so much flexibility as what they could do that we could never try and capture them all, but there's probably a few common pieces. But in terms of what's there today, it's somewhere under, I think it's actually just on the server, you can actually specify directly, I think it's the image or one of the pieces here, you can do it, and then you can store a snapshot and then use that there, which is probably the more useful one for if you've got
You
it.
can just create a virtual machine outside the firewall and then with flat.
Yeah, flat or snap, or bridge them in with an extra.
Is it possible to use multiple platforms on the same topology?
Yeah, I haven't got into that stuff much, but it certainly can be done.
Because if you can just use one flat, you create another one,
Yeah.
give you an error actually.
I think you can create a couple. We'll probably have to sync up on that one. It can be done. I don't know the exact command off the top of my head, but it's certainly doable to bridge in multiple externals. And that's kind of what that trunking piece would be trying to do.
This has been a Swinburne production.